Hi, my name is Haemy Lee Masson. I'm a postdoctoral researcher at Johns Hopkins University. In this poster session, I will present my recent work on the brain basis of social interaction perception during natural viewing. Recognizing social interaction is a crucial skill as they allow us to navigate the complex world. Previous studies found that the posterior superior temporal sulcus and cortical midline structure are implicated in this processing. Previous studies relied on simple stimuli and more naturalistic movies showing conflicting results. In our study, by adopting a movie viewing paradigm and advanced computational method, we aimed to address brain mechanisms underlying naturalistic social interaction perception and what extent social interaction selectivity exists in the real world where social interactions co-vary with many other features. We used publicly available fMRI movie data to address these questions. In the Sherlock study, 17 participants living in the US watched the first episode of a Sherlock TV series in the MRI scanner. In the summer study, 18 participants living in UK watched 500 days of a summer movie in the MRI scanner. These two data came from different labs, different movie genre, different MRI scanner. By selecting two very different movie data, we test the ecological generability of our findings. We extract a wide range of features from these movies. This figure shows the correlation across features. Red color indicates the mild to strong positive correlation. In both movies, face and speaking features are strongly correlated with the social interaction feature. To pinpoint which voxel shows selectivity to the feature of interest, we used cross-validated voxel-wise encoding analysis. The board time series becomes a dependent variable y in the banded ridge regression model. X is the large matrix consisting of perceptual and social features. Once the beta is estimated during training, using that value, we estimated the withheld board time series from the testing set and compare this estimated y with the true board time series y. If we observe high prediction accuracy in a particular voxel, when the X matrix consisting of social features, it would mean that this voxel encodes social information. First, we measured how well social and perceptual features are together predict voxel-wise brain activity. Our voxels in the brain mask are explained by full model, meaning that our model is good enough to explain bold activation. For both experiments, high prediction accuracies were found in the visual cortex and temporal lobe. Using estimated beta weights from the full model for every voxel, we evaluated the relative importance of each feature. The results revealed that, surprisingly, DNN features are preferred in most voxels. Yet, social features, namely social interaction and speaking features, are the most preferred in some parts of STS. Previous results tells us relative contribution of each feature in explaining voxel-wise activity rather than the unique contribution. Thus, we performed the variance partitioning analysis. We use prediction accuracy R from each model. To give you an example, the unique variance explained by perceptual model is equal to R power of 2 from the full model minus R power of 2 from the social model. Consequently, we could isolate the brain regions whose variants are uniquely explained by a perceptual model consisting of visual and auditory features. As expected, the auditory and the visual cortex show unique selectivity to perceptual information in both experiments. We successfully demonstrated the superior temporal sulcus showing strongest unique selectivity to broad social affective features, including an agent-unique theory of mind, speaking, and social interaction. We also found the same in the brain area implicated in theory of mind, such as medial prefrontal cortex. With respect to our research question, we found for the first time superior temporal sulcus and precuneus uniquely encoding social interactions in two natural movies after controlling for other perceptual and social information. Unlike a previous study, we did not observe the involvement of dorsal medial prefrontal cortex when other social features, such as theory of mind, are controlled for. Although the superior temporal circuit is known as a hub for general social processing, social interaction is a critical feature that uniquely contributes to STS responses. This finding is ecologically generalizable as we observed it from 2 movie data. Our study suggests that social interaction perception recruits dedicated neural circuits during natural viewing and is an essential dimension of social understanding. Thank you for listening, and if you have any question, you can reach out to me via email or Twitter. We also have preprints in bioRxiv for this study. Thank you.